Building on top of a gnarly bug and some DEX math, an attacker constructs a flash swap strategy that leaves a crypto protocol's liquidity pools drained of over $100 million. Wait. Haven't we seen this before? Don't worry, this isn't Cetus Part 4. Instead, we're talking about the November 2025 hack of Balancer. You see, when Balancer was doing its math on your transaction, there was one small step that would always round a number down. A small thing maybe, but when you're a galaxy brain hacker with all the tools of DeFi at your disposal, you'll find a way to lever that up into millions of dollars. Let's find out how. This is Not Your Crypto Podcast.
Hello and welcome back to another episode of Not Your Crypto Podcast, our first of the new year. New year, we mean 2026. Happy New Year, Michael. How are you?
Happy New Year. I'm ready to get into it.
Yes.
How are you?
I'm good. Thank you. I'm excited to jump into this one. This is a great selection by yourself in this instance. Today, we're here to discuss what happened with the Balancer hack. This is a hack that, by my notes, took place end of 2025, so last year.
November, I think.
Yep, November. And I think at the time of at the time of crypto asset prices, I think it was $120 million USD that was stolen from an automated market maker known as Balancer. So, Michael, what made you interested in this one in particular out of all the hacks?
Yeah. Okay. So I guess what really made me interested in this one was just how much I enjoyed our Cetus series. No, I think there's a lot of parallels to that one that we'll draw, obviously, but I think what really made me interested in it was kind of going further and having another example of the way in which this kind of small vulnerability, maybe small, even like overlooked vulnerability, gets combined with the DeFi ecosystem and the tools available to participants in the DeFi ecosystem to result in value being drained.
Yes, right? A large amount of value being drained. I'm going to lay out the players in this Shakespearean play here. So this was known as the Balancer hack because the product target was known as Balancer. What is Balancer? Balancer is an automated market maker. For those who are not financially inclined, a market maker is simply someone who is selling an asset and states a price. A market maker in this instance, in a more complicated instance, is someone who sets a two-sided market, who basically sets a two-sided market. Yeah, I should just say that. They basically set a bid and ask price for the same asset. So I sell an apple, I will sell it to you at one price and I'll buy it from you at another price. The difference between the two prices is how they make money. So in this case, Balancer is a decentralized automated market maker as opposed to a traditional market maker where they take in a bunch of different data points and then set their prices accordingly. Automated market maker, it's basically that bid-ask spread, as it's known, is defined by an algorithm. So you got Balancer, which is an automated market maker. It's also based on Ethereum, which is important because that was the token that was mainly targeted in terms of draining from the pool and being able to be drained from the pool and how the attacker got their money. You then have the vulnerability. The fundamental vulnerability at hand is known as a rounding issue, which is an interesting name for it. And normally we in the security industry come up with more technically specific terms. This one is specific, but sounding like issue makes it sound not as big a deal as it was. Ironically enough, because when it was initially first discovered, its risk rating was basically negligent, but we'll get into that as well. And then you obviously have the smart contracts themselves. There were a lot of smart contracts spun up in this instance. We have our old favorite, our reoccurring character, flash swaps and flash loans. Back again, back for the third time. So I hope
it is true. That's the third time.
Yeah, exactly. So flash swaps and flash loans are all in here. And so what happened here is you basically have an attacker who spotted an opportunity and able to leverage what was a little, not respected, but a little feared vulnerability. It was initially found in 2021 but they exploited it in 2026. So that tells you what happened there. And it had been reported on every 2025. Sorry, yes. And it had been reported on every time this talks about, or this speaks to audits and stuff like that, which we'll come back to later. So, Michael, do you want to give us a rundown of basically what happened between these different actors, the balancer, the vulnerability, the attacker, and flash swaps, and how they were used and leveraged to basically drain 130, $120 million from a series of liquidity pools?
Sure. Let's do it.
Do we even want to, sorry to interrupt, do we even want to talk about liquidity pools are another actor as well? Balancer provides the ability to spin up liquidity pools. So they're another feature in this.
Yeah, like basically like, you know, as a user, your view of Balancer might be that it's like essentially a DEX, right?
Mm-hmm. Yeah.
Like I can go to a Balancer website. I can go to the Balancer website, I guess, and I can click buttons and I can exchange my whatever token for my whatever other token, right?
Yeah.
Under the hood, kind of the thing that makes Balancer what it is, I guess, and kind of differentiates it is Balancer is not like itself directly providing liquidity pools as the Balancer entity, like as opposed to like Cetus. Like if you remember our Cetus episodes, it was kind of like Cetus designs the liquidity pools, they put them out there, then you as a user can contribute liquidity to them. Balancer is slightly different in that they knock up the level of abstraction one more, which is something we talked about something we like to do for some reason. And basically what Balancer provides is like an ecosystem and kind of like a protocol for developers to build liquidity pools in their platform and in their ecosystem. And so anyway, I might be getting some of these details wrong because I have
you've got them right
as these abstraction layers.
No, but I think, and I do want to double down on this because effectively what we're doing is we're talking about an abstraction of an abstraction. So I like your example of talking about, as a user, you'd experience it as a DEX, a decentralized exchange. Effectively, what they're doing is they're creating the plumbing for anyone to spin up their own DEX. And DEXs are basically collections of liquidity pools. You see how far this rabbit hole goes, right? So you've got decentralized exchanges that are made up of liquidity pools. Liquidity pools are made up of pairs of tokens. If you remember, I think the example we used to try and bring it into everyday experience was foreign exchange. When you go to the airport or when you go to a random shop in Liverpool Street, my Londoners will be able to pick up on that one. You exchange your Canadian dollars for your euros or your Chinese renminbi for your Indian rupee. They are pairs of currencies, and it's the same thing in a decentralized exchange. There are pairs of token assets. And it's in it. So the reason they exist is to provide liquidity. They do what they say on the tin: liquidity pools for people to trade from. And Balancer creates basically white labeled infrastructure. So I can come up with a new pool that has a random exotic pair because I see a trading opportunity or whatever reason.
Yeah, or has some new logic that I've come up with as a developer for how to balance the assets in this pool to some benefit and whatever, right? Yes. And so like as a user, I can still roll up to it, use that as a DEX. I can also roll up to it and contribute liquidity as a user, right? Because that kind of like, if you remember the Cetus episode, that's something that you do as well when you use the ecosystem. And like there's reasons for doing this, right? It's not like this is just like entirely abstraction for abstraction's sake. There's reasons. It's, allows devs to build these things without needing to build their whole own scaffolding for it, which is a reason. Balancer also does some stuff like if I'm exchanging token A for token like Z, it will figure out an efficient path through all these different pools for me to do that exchange. And so there's like some user benefit there as well, and like that sort of thing. So anyway, those are kinds of the reasons for doing that. But like always, like when we, if we think back to Cetus again as well, which we're going to be doing a lot, like the important bits from the protocol level is when people provide like that, you accurately keep this mapping of the value people have provided in liquidity to the actual value and liquidity that's in the pools. So like when I come to contribute liquidity to it, some calculation happens and I get back a liquidity token that represents the liquidity I contributed to the pool. so that I can redeem it later.
Stop.
Yeah.
Let's go through that one more time, please, for our listeners. So I'm going to ask you a series of questions. Obviously,
Okay.
I'm going to play the position of a listener. So
I'll
effectively what you're saying is, it's okay, I'm not trying to trip you up or anything.
If it's not in the notes I sent you, I don't know the answer.
Yeah, that's fine. Likewise, mate. So you have this liquidity pool, and when I contribute any asset pair into that liquidity pool or asset on its own, I am given a receipt, which is a token of itself that represents a share of the liquidity pool, not what I have it's literally a share of the pool as it is translated from one token to another, or as it is correlated from one token to another.
And like, you can think about why this has to happen, right? Like, if you kind of do some first principles here, like I have I always use numbers that, like, with crypto prices sound crazy because I just don't have a mapping to like what the actual value is. Like, I contribute 10 ETH. I don't know, it's probably a lot, right?
That is a lot. That's a
I contribute 0.01 ETH or whatever to the pool. Something needs to keep track of the value that I've contributed to the pool, right? And that's not necessarily going to be you contributed 0.1 ETH. Because over time, the pool is going to change. Other people are going to add tokens. The weighting between the different tokens in the pool is going to change. It'll get balanced towards one side and then towards another as the exchange rate changes and all this stuff, right? So if I contribute some amount of liquidity, like 0.1 ETH, something needs to represent my stake in the overall liquidity of the pool.
Which makes perfect sense. Yeah.
And the way that they do that is it decides, okay, you contributed this much liquidity. I'm going to give you this new token. It mints a new token for you, which is called a liquidity token. In this specific example, I think it's like BPT is the main acronym, which I think is Balancer Pool Token.
Correct.
That we're going to be talking about. And it gives you some amount of that token representing your share in the pool. So that later, when I want to redeem and withdraw, it then runs that calculation back and knows how much to give me back. Because what you care about is your stake in the liquidity of the pool, not the actual token that you contributed.
Correct. That makes perfect sense. So,
do you have more questions?
No more questions on that one yet. So far, so simple. I get given a share back. I'm told how much of a pool I own via this BPT token, which, as a bit of a dogleg or a trajectory, you can actually trade that as an asset as well.
So this was something I had to wrap my head around. Like, that token is actually also kind of an asset. In the ecosystem that you can swap, exchange, trade, whatever.
Which,
of course, because why not, right?
Everything's financialized. So
everything's a token.
Everything, even a utility. So effectively, there we go. So now we have Balancer, and we've now got these pools, and now I've redeemed my BPT token that basically represents a share of the pool. What could possibly go wrong with this abstraction, so don't forget, you've got your liquidity pools, you then got your tokens in liquidity pools, which are an abstraction of the actual token you put into the pool. Now you've got a BPT token to tell you how much of a share you've got of a pool. So I think we're 2 layers deep at this moment in time, or 3, because basically you have your Ethereum in the pool, you then have your staked Ethereum, and then you have your BPT, which represents your staked Ethereum. So we're 3 layers deep, actually. So basically you now have your BPT. What could possibly go wrong? And what did go wrong in this instance? What did a keen-eyed attacker realize they could exploit here?
Okay. We want to talk about the rounding now?
I think we should get to the rounding. I think we should get to the meat of it quickly.
Let's do it. So okay. When I want to do operations in the pool, like I want to swap one token for another, it needs to run some math on that, right? To figure stuff out. And in particular, like it needs to do some comparisons of the 2 tokens, like token A and token B. And the math is going to and it's the same thing for when it's like figuring out how much BPT to give me. There's this formula that it runs to determine, okay, you gave me this much ETH, here's how much BPT I'm going to give you. The formula is like relatively simple as opposed to the Cetus one, which was more complicated when we got into it. But anyway, there's a formula. In that formula, it needs to compare it needs to run like operations on 2 separate tokens, like one being kind of, BPT presumably, and one being another one.
Yeah.
Not all tokens have the same precision. That's how you would put it, right? So like in terms of the number of decimal places that a token can get chopped up into, not all of them are the same. Some of them, like I think Ethereum's like, is it 18, 16? 18?
Ethereum's 18. So basically, according to my research, 18. So it effectively uses floating point math to represent its value in a decimal form, in a binary form. Whereas BPT used fixed point math, which basically the difference in reality is one has more decimal places to represent the precision and the size of a thing, and one has less. BPT had less. Ethereum had more.
Yeah, so you can think of it like 0.00000 18 times 1 or whatever would be basically Ethereum, and then I think it like a lot of like some of the stable coins are like 6, only like
basically
6
USDC is like 6 and things like that, and so automatically all the security people listening to this podcast are like, oh well. The door is now slightly ajar. It's not open.
Exactly.
Well, maybe a lock's
it's not
a bit
open
loose.
yet.
It's not open yet.
You know where the door might be.
Yeah, you start tapping there now, don't you? And so yes, let's go back in. So so basically, you've automatically got this mismatch between how precise you can represent a value or an amount of a thing.
Yeah. So you need to, in order to then do math on these things, you need them to be the same. More or less.
Computers do.
I guess 100%. Exactly. The computers need it to be the same.
100%.
So what you do is you upscale them to the same amount of precision. So if I have if USDC is 6, then I upscale it to 18, and I just like take the numbers and make it the other one. I like make it more decimal places. That is kind of a simplification. And then on the other side, when I'm done, then I need to downscale. So I need to then take that precision and then put it back into the amount of precision it was before, because that's what it actually is, right?
And now the security engineer is like, wait, we need to tap harder on this. Wait, it's going up and it's coming down. Oh, there's a gap there.
Yeah. Yes, exactly. So when you're doing these operations, upscaling and downscaling and whatever, you will encounter situations where you need to round the number, because you're multiplying things, you're dividing things to do this precision gain, I guess, and loss, or this kind of synthetic precision gain and loss. You're multiplying, dividing. You might need to round because you're trying to potentially fit infinite decimal places into less, right?
Yeah.
Anyway,
effectively, yeah.
And rounding is a known thing that these DeFi protocols do. And there's kind of this golden rule, I guess, of how you do rounding, which is when you are rounding, you always round, you should always round in a way that benefits the protocol, benefits the house.
And this is where my finance people are like, oh, arbitrage. It's kind of basically that you're doing arbitrage so that the house always wins. It's not that you round down here and you always round up there. It's whichever way benefits the liquidity protocol, so that over time, over the amount of transactions that go through, they are accruing value.
Yeah, you get some positive expected value kind of from this rounding happening. And so that's one reason, and I should assume that's the main reason. The other reason is so that you don't provide benefit to the user that could maybe be used at scale to cause you problems.
Because this is math. Both sides of the equation have to balance out. So if it goes the opposite way, it's not that we can live with it. It's no, you're losing. Either one side is winning and one side is losing. And so therefore you need to make sure you're on the winning end of that equation with the surrounding stuff. So and again, this is common knowledge. Everyone who built liquidity pools, they figured this out very quickly when they were doing the math before they even put one line of code in. So you have to just make sure, again, this is where the security engineers are going to prick up. It's okay, make sure you always round that goes in a way against the house. Okay, where? In every instance. Oh, across the entire code base? Yes. All the time? Yes. Oh, okay. And how do we do that?
Which isn't necessarily the easiest thing to think about, because which way benefits the house can be different in different circumstances and whatever, right? So in this case, there was two, like both the upscaling and the downscaling operation had rounding involved. They were not matched, so that the downscaling operations rounded to benefit the house when appropriate. The upscaling operation always rounded one way. It always rounded down. And again, contextually, whether that would benefit the protocol or not depends on kind of how you're using it and the inputs the user are giving it. But you can kind of think of a simple construction here, maybe like an example, which is like, if I contribute, let's say I'm like doing some kind of swap or something. I don't know if this example will like fully hold out, but I say like how much USDC do I need to give you or pay to get 10 Ethereum? It will round down the answer it gives me. And the answer it gives me was, how much do I need to pay?
Yeah.
And it's rounding that down. So that rounding goes in a way that benefits me as the user.
Exactly.
So the user is getting some very minimal, what would you call that? Alpha or something?
Yeah, tiny bit of alpha. And it basically, the way they translate it in crypto world is they call it dust, because the values of that asset are so small at this point. So we're talking about 0.6. We're talking about 0.6 on the, no, not 0.6, sorry. We're talking about 6 decimal places. We're talking
very low.
very, very small amount.
But
as a division of a whole token.
Yeah.
Go on.
Yeah, that is a very small amount.
Yeah.
So, if you put on your attacker hat, you want to figure out how to juice this amount, right?
Yes, you do.
Because now talk about the door. Now that there's a crack, like a crack in the door.
Yeah, there's a crack. Because now you found that there is a way in which I can.
Or it's like, when you close your door and both, like, the latch doesn't fully close, and so the wind can blow it open.
Oh, we are stretching this. I love it. But it's perfect, because every security engineer, or even any engineer that's security minded, knows exactly what we're talking about. Because I've always said security is more art than science. And sometimes you just get a good feeling about a thing. You're like, wait, what happens if I press there? There's something there. And it's always abstractions. And you've heard us say this over and over again on this podcast. It's always abstractions, because keeping track of those abstractions, and more importantly, the assumptions they make of the components that they interact with, it's beyond a full-time job. And so you end up with things like this. So yeah, the door is definitely not latched now, because there is literally a thing. I have identified there is a process within which I can get more out than I put in.
Yeah,
it's tiny amounts. So now we just need to scale this. And what are computers good at doing? Scaling. Digital world allows you to scale very quickly. You just need to figure out how. And this attacker figured out how with enter stage left, one of our favorite old friends, flash loans and flash swaps. I hate them. Go on, Michael. What do they do with the flash swap?
Yeah, so you have to think what tools, what tools does the attacker have available to them to give them leverage, right? Like to give them scale and to give them leverage. And I would say there's kind of like two concepts here that they use to really like lever this up. And one concept is certainly flash swapping. I guess it would be flash swapping, which we've talked about a number of times, but we'll get into again. And the other fact is one that we mentioned like earlier, which is the fact that this BPT token, this liquidity token, is like a tradable asset in these pools. It's like what would you call that? Native, like what do you like tier? There's some like object oriented word for this. First class.
First class citizen. Yeah.
In these pools. Okay.
Yeah.
So should we just run through the structure? Like
the
structure
go ahead.
Of the attack. Okay. So, gosh, I hope we got this right.
It's okay.
So there's going to be an envelope of things that they do here, like things within other things, of course. So, but the first step is they execute what's called a batch swap. And a batch swap, you can think about like, I think you can think about it like a flash swap. You're going to ask for a bunch of assets. going to get control over a bunch of assets. And then you're going to ask for how much you need to pay back later. They call it, I think the protocol calls it deferred settlement, which is kind of the structure of a flash swap. So, okay. In this case, the attacker is going to be like, I'm going to loan me a large amount of Ethereum or something. I don't know if it was exactly Ethereum. I think a lot of it was like wrapped tokens and different stuff like this. But for simplicity's sake, we'll probably just be saying Ethereum
because fundamentally that's true. It was just wrapped Ethereum. There's different versions of wrapped Ethereum as far as my research can show.
And then so you'll give me a lot of Ethereum, and then tell me how much I want to pay it back in BPT. So tell me how much BPT I need to pay back later. I think that was the structure of the first layer of the envelope. Okay, and that's fine. That's an operation you can do.
Yeah, that's so far so above board. That's just
so right now the attacker has kind of Ethereum in hand, and we'll talk about what that means. And they have a balance owing of BPT that they need to pay back, or the whole transaction won't go through. That's the flash swap thing, right? Okay. But one consequence of this, which I really have to wrap my head around because is that the pool that they borrowed from now has lower liquidity than it did before, because they borrowed a lot and they've left it in actually a pretty low state of liquidity.
Yes, they borrowed an extreme amount. And then again, go on.
No, you go.
I don't know. I mean, the security engineering means like, so why is that even allowed? Why is it permitted in order for one person to come and reduce a pool to such a state whereby there is barely any liquidity of one pair of the tokens without an alert going off? Because under which circumstance would you allow your pool to be drained? How is that good for you as a business? I mean, obviously, and I'm asking these as open questions. I'm not asking them as though I know best, but I'm like, surely that can't be good for business, even if you're a Cetus or a Balancer, because Balancer, the unique thing about Balancer again is it is scaffolding. It is a smart contract that a lot of people use to underpin. And this smart contract, basically, don't forget, this is blockchain world. So these smart contracts effectively host all of the assets, the tokens are put into them. So even if you have 4 different discrete businesses, if they're using Balancer and they are basically hosting the same pool, they are all going into 4 different businesses are depositing, 5 different businesses are depositing into one pool. So if it gets drained, all of them are out of business. So to me, the security engineering me is like, well, why is this even possible? Should this be possible? Should there be a safeguard against this? Do we expect, it's a protocol, are we supposed to be neutral opinionated, and therefore the apps should have alerts and being like, hey, maybe they did in this instance, I don't know. But number one, why are you able to drain down to dust levels?
Yeah, I don't know. I think probably, I don't know exactly. I think there's maybe an answer that's like the math works out, because this is all within one transaction. Nobody else is interacting with it while this transaction is going on.
That's true.
So it gets refilled at the end.
Yeah.
So whatever. But I agree that there is a pattern of this capability being used to leverage attacks, but that also means that it gets used to leverage regular DeFi stuff.
Yeah.
Right? So I don't know.
Yeah, you're right. Actually, my question's kind of null and void. Actually, yeah, it's a good point.
Well, anyway, but I think for the attack, leaving the protocol in this low liquidity state, I think is going to be part of how it gets leverage, how the attack gets some of its leverage.
Yeah.
Because it means that to get the same amount of BPT within, if I do further operations here, to get the same amount of BPT when it's in low liquidity, I need to contribute less. Because the overall pool is smaller. And so if I contribute a share, that share is going to be larger.
Yeah.
Does that make sense?
No, it does make sense. So I took a while to get my head around this as well. So effectively what happens is the overall total value of the pool has decreased massively. So therefore the amount you need to own a larger share of the pool has decreased proportionally. So this is what the hacker realized. And effectively they then go back to that rounding issue that Michael was discussing earlier, where in the smart contract, they obviously had to change downscale, then upscale, or upscale, downscale. The point is, we lost levels of precision, and the attacker was able to abuse this because now I'm able to buy a share of that pool. And remember what we said when the door wasn't latching properly. The thing they've realized is I can buy a share of that pool for less than would normally need, But basically, I'm able to buy a share of the pool, and the amount I need to provide for a said share of the pool gets rounded down, and I get a larger share back, basically. In so many words. Does that jog your memory, basically?
Yeah. And I think the kind of where the rounding error comes in is if the liquidity is low enough, if the liquidity left in the pool is low enough, then remember we said that there's layers of things. There's this outer batch swap that they did. Within that, they can do more transactions. So if the liquidity is in a low enough state and I ask to do another swap, is that it? And I
yes.
say, or
no, because you're
whatever.
buying a share of the, yeah, it is a swap because you're buying a share of the pool, right?
Yeah.
So yes.
I can say to the protocol then, I want this amount of BPT. I'm now doing another transaction kind of within that overall envelope. I want this amount of BPT. Tell me how much I need to contribute. It's possible you can get it into a state where, because of the rounding, because it rounds down that upscaling operation, the answer it comes back with is 0. Is rounded down to 0. So I want so the pools in this has low liquidity. I want a share of that liquidity. I want like 1 BPT or something. How much ETH do I need to contribute to get that? Does its math. Okay, when I'm upscaling the ETH, I'm going to round it down, blah, blah, blah. Oh, answer is 0. It's been rounded down to 0, and the math like zeroes out those operations.
Yeah. But I think it was reversed, right? So basically it was how much BPT do I need to contribute to get a share of this ETH? Basically, and that was what they kept. They had a dust value of amount that they kept pumping in, saying, "Okay, to get a larger share of the pool." No,
I don't think so. I think it was the other way around.
Really,
they have the ETH in hand from the batch swap.
Okay.
So what they're trying to accumulate is a BPT position to pay off their receipt at the end, and leave them with the ETH in hand for free.
Yeah. Fair.
I think.
Fair.
Well, but I think you could maybe construct this attack either way.
Yes. I don't know why not, because you're trying to redeem the assets in the pool. So basically you're either supplying BPT or you're basically trying to buy a bigger share of the pool while supplying actual assets and getting BPT back. So I feel like it is a reversible thing unless there's something we're missing. If you do know what we're missing, writing answers on a postcard, please.
But yeah, so like going back, so Structure, they've borrowed a bunch of ETH. They said, I'm borrowing a huge amount of this token. Tell me how much BPT I need to return at the end. It says, okay, you need to return this amount of BPT at the end. Then within that transaction, they run a whole bunch of smaller transactions where they ask over and over again, okay, I want this amount of BPT. I want 1 BPT. How much ETH do I need to pay? How much liquidity do I need to provide? And it says back 0, 0, 0, 0, 0, 0, because it's rounding down. And so they're building up this BPT position through these smaller transactions that they're doing.
Yes.
And then at the end, they have to pay back the BPT, which they've built up. They've accumulated the position to do, and they've accumulated that position for free without providing actual liquidity, because the protocol kept saying back to them, you need to provide 0, you need to provide 0. So that means that they can pay back the BPT and they still have the ETH in hand. So then, and from the protocol's perspective, legitimately, they legitimately have that Ethereum in their account, in their ledger, the balance, right?
Yeah.
So then they can withdraw that, and nothing will stand in their way, because to the math of the protocol, or to the code, to the smart contracts, it's ascribed to them.
Yeah.
So basically, like, it's another situation where they've been able to kind of almost, like, I use the word depeg. I don't know if that's correct, because I know that has specific meanings, but they've been able to like depeg the value of the liquidity token from the actual liquidity being provided. And so they kind of construct liquidity for free, or make the protocol think that they've constructed liquidity for free.
Yes.
if that makes sense.
I think that is a perfect analogy of what's happened. I don't know if I'm just trying to think why I'm slightly uncomfortable with the word depeg, because the ratio, I don't think they changed the ratio of whatever ratio was governing the values of the pair of assets in the pool to each other. I just think they basically reduced it to such a point where the math, obviously with the upscaling and the rounding down, changed how much the cost of buying into a pool. So I don't think they depegged the pool per se. They just changed the cost to make it so low, and therefore they were able to draw out, or not even draw out, extract BPT at basically nominal values, that they were able to garner a larger share of the pool and then obviously cash that out. So I don't think they depegged what the values were of F to state Teth or whatever.
No. Yeah, the pegging is the BPT to the liquidity in the pool.
Okay, got you.
Asset one to asset two within the pool,
sorry.
Which is why it's a confusing word to use in that situation. I think.
Got you.
Yeah.
So there you go. Crash course through rounding issues. And they, as a result of this, they were able to walk away with $120 million. This wasn't from a single pool, because as we said, this was plumbing for a bunch of different pools. So you don't even need to know what balancer is to actually have been affected by this hack, which is the unfortunate thing about it, because they found the vulnerability in what was a particular contract that was particularly used for specific types of pools where that so-called bid-ask spread was effectively parity, because it's a stable coin. So obviously stable coins are supposed to do exactly that, stay stable. So therefore it's a one-to-one thing. And they targeted that particular contract. And that contract was being used to support a bunch of different pools by a bunch of different third-party applications. And so they drained a bunch of them. Now, this is where it gets interesting, because in order to access a flash swap or a flash loan, you effectively, or balancer as well, you do have to create your own smart contract. And in this instance, when the analysts went through the hack and started picking over the debris, they found that, I think I read somewhere, almost 40 different smart contracts. That number may have changed because that was in the initial days, and as we found out, what was discovered in the initial days after the attack is very different to what we know now, because people were rushing around trying to find out exactly what was going on accurately. So they were up to, we'll just say now, 40 different smart contracts. That's a lot of coding. And then when people actually started to pick through the smart contracts that were used to actually exploit the vulnerability, they started to see dead giveaways for vibe coding. We call it vibe coding. I don't know why we call it vibe coding. Anyway, AI assisted smart contracts. And people started to realize that the attacker had used AI to write these smart contracts. I find it funny that is even a headline in this, because I'm like, well, if people are using AI to build apps, why wouldn't you just use it to build?
Yeah, I assume that they would, right?
Yeah, I mean, that was a given. I do have some random takes on that, but yes, so we'll get into that in a second. So yes, people realized that AI was being used. That was one of the big headlines.
I think to me, the question about that is like, like obviously if somebody's not going to just write the smart contract code necessarily like by hand, you're going to use assistants to do that. And I think the smoking gun was like that there was these basically debug logs in it that you would remove because they cost gas. So like, why would you leave them in a production thing, right? I think to me, the interesting bit is like, I think people might make a further assertion that not only was like the smart contract development AI assisted, but like was the actual issue discovery and like, hack, like building the chain and all that, was that assisted? To what extent was that assisted or automated, or like hands off, hands on? And I mean, can't really.
Yeah, I mean, I think, to me, okay, fine, we're going into the AI part. To me, that's obvious. I hate the phrase obvious as well. It's overused. But to me, it's obvious, right? Because if you do static analysis and you come out with a vulnerability, you then are going to be able to, if you're a white hat, you then report it. And if you're a black hat, you sell it. And if you just happen to have a static analysis tool that is AI assisted, then it's the same thing, right? So I think it's obvious. To me, it's an obvious next step. It's, okay, let me just start analyzing whatever random contracts out there. Where's the value? Let me find out what vulnerabilities or potential vulnerabilities are there. And let me see where they're exploited. I think in this one, it could even be as far as, okay, I used to have this conversation when I was a pen tester, and I used to get very frustrated when the client would look for the report and be like, okay, where are the highs and the criticals? And I'm like, dude, you could have 6 lows strung together and automatically you've got a high. So I wouldn't do that. I wouldn't pin my hopes, not even pin my hopes. Don't orient yourself around the risk ratings, because necessarily if you chain a bunch of vulnerabilities together, you can have them chained to a devastating effect. Arguably, that's what management summaries were for in reports, but nobody ever read those. They just went straight to the table of findings. We're like, oh, 3 mediums and 2 lows, we're good. And you're like, no, don't do that. Because what I'm building up, my point I'm building up to here is this vulnerability, as you said, had been discovered in 2021 and was exploited in 2025. And in each, they did everything right here. And again, when we look at these hacks, we're looking to learn from them. We're not here to denigrate anyone's efforts or look down upon. So effectively what you're having here is you've got a balancer, you've got a third party, they've built this balancer thing. They've then said, okay, we're going to follow all security best practices, which is annual reviews, audits, having 2 different well-established auditing teams go over different scopes and sometimes share the same scope in terms of what they're doing. And this vulnerability was caught. Nobody knew whether it could be exploited at the time. They didn't know the level of sophistication would obviously go this way. But at the same time, everybody knew of the vulnerability and it did exist. So what you could have here with the swinging back around to the AI assistance thing is you could have someone who just takes your audit report, shoves it into an AI bot. Like, it's not beyond the realms of possibility of them going, okay, please,
no, certainly not.
Let me know whether this now is actually exploitable. I don't even know the math here. I'm not as galaxy brained as that. But if you can assist me, which is the whole point of AI bots now, and that's probably what happened. Then they're like, okay, no, can you take this from theory to practicality? Yeah, sure. We all know how Gemini and ChatGPT speak. Yeah, sure. You're a genius. Here's the 40 smart contracts. This one isn't working. Oh, here's a bunch of deep console.log messages. Okay, we've now figured out where the problem is. So I think I would go as far as to say, in my opinion, this was a wholly AI assisted attack, which brings me to my first random point.
Okay.
Because obviously this is only ever going to increase, and AI is a tool. So by definition, it's neutral. It depends on how you use it. But I'm like, if these LLMs, they know the code, what they're doing when they're writing the code, i.e. they know what the code is written to do, the whole purpose of it. So at some point, does liability come into the question? This is going to be a random pivot, but for example,
I did not expect that.
Yeah, because I was thinking about this. I was like, I am aware of cases in the US where gun manufacturers have been taken to court because it's like, well, you've sold this gun and there was a bunch of safety mechanisms that weren't implemented properly, or it was sold to a negligible the manufacturer sold it to a negligible reseller who wasn't doing safety checks or whatever, and so they went on to do something bad with this gun. So you are liable for not implementing any controls at any point during this entire kill chain, right? And so I'm like, is there could you imagine a world where, okay, this LLM is writing this code and knows it is being built to exploit a vulnerability somewhere on Tinternet? Could these third parties who are being exploited turn around and say, hey, LLM manufacturer, ChatGPT, all these large companies who are training these models, have you got any, just let us know if you've got any safety controls. If someone rocks up to your chatbot and says, I want to hack XYZ, can you scan the website? Will it automatically turn around and say, I am not built to do that? Or does it say,
I mean, some of them do.
Okay.
So some of them do for sure. It's not, it's not impossible to jailbreak out of.
Obviously not. Yeah.
But some of them, I would say all of them that I've interacted with do for sure have that. And I think some of the companies also are actively kind of behind the scenes looking for these things. Like there was that reporting from Anthropic
right? Yeah.
About just like disrupting a state actor that was orchestrating a offensive campaign through their models.
Yeah.
So some of them do also have some backline monitoring to
and that's what. So I was thinking of that, and there's another mechanism, for example, in the US, whereby if you go to buy one gun, if you go to buy more than 2 guns within 5 consecutive days, they automatically fill out a report. The seller, the merchant, fills out a report and lets local law enforcement know. So I'm wondering, okay, if an LLM if they start to see that someone is, even if they're don't even need to jailbreak, they're doing it for research purposes, but it's obviously a Solidity contract. It's a bunch of Solidity contracts they're spinning up. Is there some method they could use whereby they actually alert and just be like, hey, we're seeing this kind of behavior when it comes to security research, just to let you know? Obviously, it could be could be a white hat such as ourselves doing research, or it could be a black hat, but these are the steps they're taking. These are the things they're starting to look into. It could be an annual report, could be a semi-annual report, who knows? But I was just thinking, at some point, if AI is as powerful, AI is already powerful, and if it's going to get more powerful, I think there needs to be a different level of safety and controls implemented to make sure that these things aren't as easy. Obviously, a determined attacker could just train their own LLM on their own box and then basically get it to do whatever they want, because they can dictate what controls they have on it. But yeah, I just thought, okay, liability is going to become an issue because you're looking at 130 million walking out the door, and it was partially possible simply because of the existence of AI. Whether this person would have been able to, or this group would have been able to execute this attack or take advantage of this, is a different story, because as I said, it was knocking around for 4 years. So the AI thing is one thing. The next thing is, this is inside baseball for all our security engineers. Discovered but underrated is what I've written down in my notes. This bug had been knocking around for 4 years. And they did everything right as far as security practices go, and yet it still got exploited to devastating effect. And this is one of the funny things we talk about, is the threat landscape. It's one of those classic wartime metaphors we use in security that is very annoying. But yeah, the threat landscape changes and actors get more sophisticated. And so now your unrated vulnerabilities, your low risk vulnerabilities, all of a sudden become highs and criticals. And even though they probably have their own internal team, you then have these external teams who are then doing these extremely thorough audits. You're publishing them publicly. You're doing everything right. You still get done in by them. And it's like, okay, so is there a question that needs to be asked here, is what is the ideal strategy to deal with vulnerabilities in a so-called changing threat landscape, where the complexity is such that even if you're doing everything right, you're still not immune from this?
Yeah, there's a lot, right? I think there's a couple ways, like a couple things that this makes me think of. One, I think, the core thing is, like, it was discovered 2021 or whatever. At least that's when the auditing that they've referenced was released. You talked about, like, chaining together a bunch of low value stuff can lead to a high value thing, like, absolutely. And then I think the other aspect you talked about is, like, some things only are a vulnerability when the ecosystem around the thing and the context around the thing is in a certain state, or like develops to a certain state, right? Like, like in the absence of flash swapping as a capability, this is not nearly the same thing, right? Or like, so like that's what you're getting out with the threat landscape. Like, it needs to evolve to a certain level for this to be a vulnerability, right? And I think that's what we talk about also with, like, what layer of the stack is the vulnerability resident in. And this is a place, and that gets really tricky when the layer of the stack of the vulnerability is resident in is different than the layer of the stack where it gets exploited from, kind of, right? So, like, in this case, like, this is a rounding error, right? It's like a math error. But that rounding error influences, like, the business logic. I also don't like that term, but the business logic of the protocol, and it's actually using that business logic a certain way with tools that are in the ecosystem more broadly. That makes it a problem, right? It's like that's a really gnarly set of circumstances to kind of obtain.
It's the definition of complex, right? It's a problem that shifts and changes over time. It's not complicated. This one's definitely complex, and I'm minded to be like, this is why I believe in the keep it simple, stupid, the KISS principle, because effectively these layers of abstractions, as I said, we counted 4 layers of abstractions, all representing a thing, how much money you put into a pool. That's kind of basically how much money did you and your mates pool together in this business, and how much yield are you going to earn as a result. That's kind of what we're talking about here. And there's so many levels of abstraction. You do have some of the best security researchers in the world auditing your smart contracts, and yet it still happen because it is complex. The environment around it is evolving. Your product is being used in contexts you can't anticipate. You know what it does, fine. But then you then hire these really cool, smart security engineers, and they are looking at it as a series of components because they get a limited amount of time with it, as do your external auditors. So they say, okay, we've got our heads around the 4 different levels of abstraction here. I'm just arbitrary number 4 or 3 or 4, sorry. Either way, they will look at it as components and they'll look at it how they're chained together. But then each of these components have their own complexities or complications and idiosyncrasies. So they've got to get their head around that. What's the risk around each one of them? What can actually happen to each one of them? And they tend to look at them in isolation. Michael, you do that one. I will look at the pool. You look at this. And that's how we do it, right? As security professionals, because you've only got a limited amount of time. And then on top of that, you've got how they interact with each other. So now you've got a set of permutations in terms of what could happen that just kind of explodes. If you look at your if you look at your combinatorics or something like that, or your permutations and combinations, you're like, this could go wrong in so many different ways. And again, because of DeFi and blockchain financializing everything, this is not saying this doesn't happen in Web 2. Of course it does, but it's a lot slower. The velocity of exploitation is a lot slower because not everything is an asset that has a direct correlation to real world fiat currency. So this is where I'm like, I think DeFi, I don't know, it sounds like I'm lecturing DeFi and I really have no right to be, but at the end of the day, once I started going into this, I was like, more bloody abstractions. This is what we've got here. And you always invite opportunity for something to get lost in the detail when you have so many abstractions, because there's only so much an entity, a person, a team can do in a specific amount of finite time when you're trying to run a business and make profit. So I feel like abstractions are not your friend. It's like, maybe that should be another code name of this. Abstractions are not your friend. They make things more complicated. I don't care how galaxy brained you think you are. At the end of the day, complications and complexity is the enemy of security. Oh, have I read that somewhere? I must have read that somewhere.
Yeah. I think that's like
yeah, I think I have, but I've just naturally arrived there with my own. But from first principles, I think the abstractions is the problem, and I think you're going to continue to see this in DeFi.
My other thought with this vulnerability was known or whatever thing is like, with you talked about this with like the team only having so much time, so much resources, whatever, right? Like, it's very difficult to tell from the outside whether the team, like, it's possible that the team behaved entirely efficiently and correctly and best case with the resources that they had, because you don't know what the opportunity cost of looking into this low or like unrated rounding error on this report was versus the other stuff that they were doing, right? And like, it's possible that, if you do some like parallel worlds stuff where they decided to focus on that instead of something else, something even worse happened over here, right?
100%.
So like, just the fact that something was known, like, it's easy to kind of point to and look at like post hoc, and make assertions and whatever and that kind of stuff. But it's actually like difficult from the outside 100%. To say what the 100%. Counterfactual would be.
Yeah, you're echoing my point there, because it's like, as I said, if it wasn't this, it would have been something else. We had 4 layers of abstraction.
Potentially,
and we saw it with simple. Cetus wasn't as complex as this, but Cetus isn't as overloaded with abstractions as this, but it's close to it. And I'm just like, oh man, I think one way, if you're going to try and say DeFi is the platform of the future when it comes to, as we always come back to first principles of why we think the technology is great, it should be serving people. Decentralized finance could be one of those tools, one of those platforms that helps people interact with the world of finance, or high finance, so to speak, easier. If you're going to say, I want to onboard people, you need people to trust you, and people don't trust complex things because they know inevitably, not because they're scared of it, not because they're not as galaxy brained as you, it's because they know every time you see, when humans build complex things, inevitably a human with another galaxy brain finds a way to undermine it easier or simpler. And so therefore, keep it as simple. Exactly. Keep it as simple as possible, where everyone can see the so-called vulnerabilities and they're easier to patch, so to speak. That's, I don't know, my flawed opinion, but I don't think complexity helps in this case. And I think we should stay away from obstructions as much as possible, because at the end of the day, these guys did everything right, man. Everything right. And that's one of the scary things about this one, compared to even Cetus or Beanstalk or Sonium, which randomly comes to mind. I don't know. But these guys did absolutely everything right and still got done. Right, we're looking at 54 minutes. So I think those can be our concluding thoughts. We apologize for this one running over, but we had to soapbox. And we're going to soapbox more. We're definitely going to soapbox more. Yeah, I think we should soapbox more, Michael, because we've got all these years of experience, and I'm sure people listen to us too, not just for the headline grabbing stories, but also to learn from us and provide value. And I think we have earned the right to have some informed opinions on how you should go about these things, whether you're a builder, whether you're just a casual observer from the outside, or whether you're someone who wants to get involved but is scared of everything. We try and just illuminate things so you have no fear, but also know how to just basically approach these things in a more informed way. So yeah, thank you for this one, Michael. It was great researching it, realizing again it all comes down to the math. And so I have nothing else to say. Anything else you want to add on?
Oh, dude, I do have a final soapbox I could do, but do we have time? We can cut it if we don't.
Yeah, go ahead.
Okay. The other thing I wanted to mention was like when this hack happened, we had that episode a long time ago about the open source security stuff and what the consequences of that were, right? And when this hack happened, there was a lot of information that came out, and a lot of it was like not correct. There was a real mix of correct and incorrect info. And one thing in particular was that, and it was even confusing me when I was researching this, right? A lot of people just saw the withdrawal transaction. And like out of the ether of reporting and posts and whatever on this, there was this like assertion or conclusion that there must have been some kind of authorization bug or authentication bug or something in the withdrawal function, and that was the hack, because that's what was like seen, right? And it just made me think of that episode we had about the open source security thing. And even today, you like if you're Googling around, which we were doing, or asking LLM models about the attack or whatever to try and like figure out what happened, you will get back information that's incorrect about the sequence of events here and like where vulnerabilities were and stuff, because they've been like that information has been encoded now in the internet brain in a way that's difficult to root out. And so you need to be really like questioning stuff and like trying to go down to the first, like really down to the ground truth of what happened to pull it out. And just made me think of that open source episode. And like, it's great that like we can only do these episodes because all this information is out there. But a consequence of that is that there is correct and incorrect information out there, and you need to be like really like cognitively secure when you're going through and figuring out what's going on.
Exactly. You know? And I would just like to add, this is why Michael and I, when we do this research for these episodes, we literally, most cases, take it to the smart contract code. We take it to the actual blockchain transactions and go and look at all of the block explorers. Where it gets complicated is finding out what you're looking for. And so that's why initially we start the Googles. And yeah, you come across misinformation that can send you on a random wild goose chase for another next 2-3 hours. And as he said, it's encoded in LLM. And I think it's fascinating because it's a lot of this information is presented as official, and we're talking within hours. Crypto moves quickly. And it's funny because obviously I've been on record as saying I love the transparency that crypto has when it comes to doing a incident response report and the lessons learned. But it happens too quickly almost. It's almost as quick as the money going out the door is attribution and explanation. And you're like, wait. But that doesn't make sense because that contradicts that. And then so, yeah, Michael and I have to go to the code, etc. But again, I think you said this in your notes. I would rather have it than not have it, because there are still some massive Web 2 hacks that happened in the 2010s that I still
I have no idea.
We will never know the truth of.
No.
Never know. So I'd rather have than have not. That way people can learn. All right, thank you for that, Michael. I will not be cutting that. I'll be adding it. I'll just move it around a bit. All right, thank you for listening, and we'll join you on the next episode. Thanks for listening. If you enjoyed this episode, feel free to check out other episodes where we discuss topics such as the Cetus compromise and its on-chain consequences, or what happens when Sony tries to enforce its IP protections on-chain. Also, don't forget to subscribe so you won't miss out when our next episode drops, and feel free to tell a friend to tell a friend.